सर्वेभ्यो नमस्कारः नमो नमः अंदरिकी नमस्कारमुलु. Today is the second day of our classes on Vedic mathematics by Dr. Goutham Mukherjee ji. As I have already briefed yesterday that we have completed half of the topics, and now we are on next part of the theory work, course work. We are starting with the Vedic mathematics. Then we will go for Shodasa Samskaramulu. Then Ramayanam, Mahabharatam. And then other research topics, Vastu, etc. Now let us start the session paying respects to our country by reciting Vande Mataram, please. Challa Chatiba, let us request Challa Chitibabu Garu to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayajasitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajosna pulakitayaminim Pullakusumita drumadala shobhinim Suhasinim Sumadhura bhashinim Sukhadam varadam mataram Vande Mataram Vande Mataram.
Vande Mataram. Thank you so much, Challa Chitibabu Garu. And now we'll go for Prarthana. Let us request Jai Shri Garu to chant Prarthana, please.
Andarki namaskaralu. 1 minute meditation, 3 times Omkaram. Oh. Oh. गणानां त्वा गणपतिगुं हवामहे कविं कवीनामुपमश्रवस्तमं ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनशृण्वन्नोतिभिः सीदसादनम् ॐ श्रीमहागणाधिपतये नमः। ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती धीनामभृत्यवतु। ॐ श्रीमहासरस्वत्यै नमः। गुरुरेव गतिः गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे। न गुरोः परमं शिशुरस्मि गुरोः मतिरस्ति गुरो मां पाहि गुरो। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ शान्ति शान्ति शान्तिः मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः सर्वेभ्यः नमो नमः
సర్వేభ్యో నమో నమః. ధన్యవాదములండి జయశ్రీ గారు.
ధన్యవాదాలు సార్.
Thank you so much. Now going forward, let us request our Guruji, Dr. Goutham Mukherjee ji, to start the webinar, please.
धन्यवाद. सर्वेभ्यो नमो नमः. Is my audio clear and with no sound, background sound?
Yes.
I'll start the presentation. Okay, as I told that today quickly I will go through certain parts of the certain next topics like division by Nicola method and recurring decimal and divisibility. Now quickly I go through this. This is very trivial. So already it is the presentation is shared. So kindly go through this division by 9, division by 9 again with large thing and division by 8. You still go through so that you will understand. I will start from here. The actually idea is, suppose I am asked to say 111, I want to divide by 89. Now, this is very trivial. So let's say start with here 222 divided by 87. So here I have to not in normal conventional division, I have to know the tables of 7, table of 8, and then multiply with proper thing and subtract, because the division is repeated subtraction. So that principle is followed. But here, what happens? We in very first step we divide it by the nearest tens power. What is the nearest tens power of 87? It is 100. 100. So if I divide the 222 by 100, what happens? To this line I have drawn, that 22 will be my remainder and 2 will be my quotient. So 2 will be my quotient and 22 will be remainder. But we are, instead of dividing by 100, I'm dividing by 87. I'm just telling the concept. So which is 13 deficient from 100, from the nearest tens power. So therefore, that will contribute each of these 100. In each 100, there will be 13 will be contributed. So therefore, I multiply this 2 with 13, so it becomes 26 will be contributed over my remainder. So therefore, my quotient will remain as 2 and remainder will add up whatever remainder we would have gotten by dividing by 100, I will add this 13 two times, the deficiency 2 times, and I get the total remainder as 48. So the procedure blindly is that similar you do Nikhilam Navatas Charmadasito, 9 minus 8 is 1 and 10 minus 7 is 3 and 13 into 2 is 26 and add up these things. This is the procedure. But background is there that as if I am here also. Here Nikhilam 9 minus 8 is 1 and 10 minus 8 is 2, or 100 minus 88 is 12. 12 is deficient. 3 times 12 is 36, and then this becomes my answer. I come to higher numbers. 888. 1, 2, 3, 4 divided by 888. So here also this Nikhilam, it gives 112 as my deficiency from the next next higher power of 10, next power of 10, nearest power of 10, and this was I just 1 into this, I just add up from this 1000, the 112 is contributed. So here also I can say that had I divided it by power of 10, namely 1000 here, I would have gotten 1 as quotient and 234 as remainder. So, but here it is, this contribution comes from the deficiency, and then I add up and then get. Here also, here say 2, 3, 4, 5, I divided by 7, 8, 9. 211 is my deficiency, and they multiply by each of these 1000 will produce this much deficiency. So I multiply just these two. Procedure wise, this is just multiply and then come here, and this is the concept. This is the concept that I add up the deficiency with the already existing remainder. Now I come to slightly more thing contributed where complicated cases. Here it is this one. Here also it will contribute not only on the remainder but also will contribute towards quotient because of this deficiency. So 89 is that divisor, and I am dividing 1111. So here the procedure is that 1 into this 11 becomes 1 here and 1 here, and then this add up 1 plus 1 is 2. This 2 multiplied by 11 is 22, and then I add like this. But you write 1 here. Actually it is 10. 10. The invisible 0 is there, but do not write it. So 1 plus 2 is 3, and 1, 1, 1, this is 4, and here also 1 plus 1, 2, and this. Sometimes the 2 steps are required. Anyway, this you go through. So as it becomes further and further from the 10th power, you see that 2 steps are required, sometimes 3 steps. And here one example is given, 5 steps are required. So then I commented here the basic method is state division for the above problem. So this particular Nikhilam method, it doesn't become fit here, and we have to go for state division, which we'll be learning shortly. So any concept problem here? You go through this one, you will get it. Say, let us take this example: 1, 2, 1, 4, 5, 6 divided by 7, 8, 9. 9 minus 7 is 2. 9 minus 8 is 1, and 10 minus 9 is 1. That is all 1000 minus 7, 8, 9 is 211. So 211 into 1 is 200. You write like this. 21 comes here, and it comes below this 1. So just you shift 1 always. Then again 2 plus 2 is 4. 4 into this 211 becomes 844. And again 1 plus 1 plus 8 is 10. 10 into 211 is 2110. So this, when we add up like this, 6 and 5 plus 4 plus 1 is 0. 2 is actually below this. The whole 21 is here actually. So this 5 plus 4 plus 1 is 0, and then 4 plus 1 Oh, so 5 plus 4, 1 is a 10. So 10 remains, 1 is there. So 4 plus 1 plus 4 was 10, and this becomes 10 along with the carry, and plus 21 is 31. So you see it clearly, 31. But 3106 cannot be a remainder for 789. So again, 3106 has to be divided by 789. So finally, we get 3 and 739. This 3 is contributed towards the quotient. So 153 becomes my quotient, 1739 remainder. So you go through this example, you try this because it was already discussed very broadly during my session on the first course, first level course. So if any problem comes, we can discuss further. So today I skip through this one, Nikilam method. Sometimes what happens, there is again there is a sub-base technique. I want to divide 1011 by 23. So 23 into 4 is 92, and actually I divide, first I divide by 92. Then 1011 divided by 92, the efficiency is 8, or okay. Then this 1 into 0, 0 comes here and 8 comes here. Then this becomes 91, and this 10, 91. But 10 is my quotient when divided by 92, but actually we are dividing by 23, so to multiply by 4. So 40 becomes my quotient and 91 my remainder. But 91 actually is 3 times more, 23 will be fitting near into it. So therefore, I add up that, and this here just I consider not any procedure, but simply by logic or the conventional method, you can say 91 I divided by 23, so it gets 3 remainder and 23 as my 3 as quotient and 23 as remainder. That 3 quotient adds up to 40, and it becomes 43 quotient and 22 remainder. So just go through again and you'll find it. And then comes the opposite one in the division, and here it is above a base, where the divisor is above base. So 111, so actually minus 12 is my deficiency, or 12 is excess. So minus 12 have to be the same Nikilam like procedure I follow, except there will be, instead of a vinculum is not always very suitable to write. So better to write like this also. You can alternatively write like this, minus 1, minus 2. This 1 into minus 1, minus 2, because minus 1 and minus 2 here. And again 2 minus 1 is again 1, and this minus 1, minus 2, minus 1, minus 2 comes here. 4 minus 2 is 2. 3 minus 2 minus 1 is 0. And is 12 minus 1 is, or 2 minus 1 is 1. So 11 and 0, 2 becomes my 11 is the quotient and 2 becomes my remainder. 2 becomes the remainder. Now 1, 1, 2, 3. I'm dividing 1, 3, 4, 5, 6 by 1, 1, 2, 3. So here also, what is that nearest tens power is 1000. So what is that deficiency? Deficiency is the opposite. Minus 1, minus 2, minus 123. You write like this, minus 1, minus 2, minus 3. It will be very digit wise, you can handle it. 1 into this minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. 3 minus 1 is 2. 2 into this minus 1, minus 2, minus 3 becomes minus 2, minus 4, minus 6. 6 minus 6, 0. 5 minus 3 minus 4 is minus 2. 4 minus 2 minus 2 is 0. And 13 minus the 1 is 12. Or 3 minus 1 is 2. And here it becomes my 12 becomes my quotient, and minus 20 is my remainder. See, minus 20 cannot be the remainder. So we subtract 20 from this 1, 1, 2, 3, becomes 1, 1, 0, 3. And obviously it will be, because I have overestimated the quotient, so it will be less by 1 because of this negative sign. So here 1 quotient is below, because 12 into 1, 1, 2, 3 minus 20 is same as 11 into 11, this 1, 1, 2, 3 plus 1, 1, 0, 3. So you just see it, think it properly, and we discussed it earlier. Paravarti method, again I contribute. There are more steps are there only. 2, 3, 4, 5, 6. I am dividing by minus 123. So minus 2, minus 3. So 2 into this is minus 4, minus 6. 3 minus 4 is minus 1. Minus 1 into minus 2, minus 3 is 2, 3. Positive 2. 6 comes here. 5 plus 3 is 86. And here becomes 0. And it becomes minus 1 and 2. Basically 2 minus 2 vinculum 1. It becomes 19. I learned earlier. 20 minus 1 basically. So 19 here and 0. And remainder 86. This is also another technique. 100, I express that 118 as 1, 2, and minus 2. One vinculum, 2 minus 2, 2 vinculum 2, equivalent to this. Here I write with this one. This is another technique they have followed. And it becomes like this. So this is about, here also special cases are there that you just go through. If any problem comes, you'll tell me. So 224, because 224 cannot be directly handled. So 112 I have to handle, and 112 if I do, so it is minus 1, minus 2. I follow that same procedure. 2 into minus 1, minus 2, minus 2, minus 4. Then 4 here, 6 minus 2 is 4. 4 into this one becomes minus 4, minus 8. I add up. It becomes 24 my quotient and 11 remainder. But actually, instead of 224, I divided by 112. So it will be halved. So 12 will be my quotient and remainder will not be disturbed. Remainder will be. So something I am dividing by 112. I get 24 remainder and 24 quotient and 11 remainder. If I divide it by same thing by 224, obviously I will get half the quotient. So here actually comes a half comes. That is very detailed. In details it will discuss. If you go through the half in, as I told, half in a particular digit becomes 500 or 50, depending upon the case of that position. So that or add up and finally get. This is very complicated, so it will take much time. Division there. Now, so division is okay. That was the division where I finished up getting a quotient and a remainder. But when we have the concept of fraction and decimal form, we proceed towards writing the in this form, in the fraction form. When we divide by, say, E is my dividend, and I'm dividing it by D, so I get a quotient and a remainder. Actually, so D into Q plus this dividend into quotient plus remainder, it becomes my divisor into quotient plus my remainder becomes my dividend. So if I divided both sides by D, becomes E by D is equal to Q plus R by D, and R is always less than D, because as you know that remainder should be always shorter than, smaller than the divisor. So it becomes R by D is a fraction. Now this, in the earlier sections we ended up here. Only we found the Q and R. But here, this R by D you have to handle. How? Now, depending upon the requirement, we sometimes keep it like this. I call it 15 by 4, I call it 3 by 3 full and 3 by 4. But this also can be expressed as a decimal form. Now, this E by D becomes E less than D can be expressed because of this one. And we finally, instead of R by D, we call it N by D, numerator and denominator. Now, numerator and denominator, then we follow like this. And there are various categories. Any rational fraction of the N by D becomes a terminating decimal. When becomes terminating, when terminating, it's purely comprising of powers of 2 and 5. So always you'll find half is 1 by 2 is 0.005, sorry, 0.5, 0.5, and then 1 by 4 is 0.25 and 0.75 and so on, 0.125, and they all are power up. The numerator, denominator is always power up, purely power up 2, and power up 5 also similar. This is also purely terminating. 3 by 5 is 1 by 25 is 0.04, and so on. 50, purely 2 and 5, so 0.02 and so on. But a rational fraction whose denominator ends up with this, you remember this, 1, 3, 7, and 9, becomes purely a recurring decimal. 1 by 3 is 0.3333, going like this. 1 by 7 is 0.142857, 142857, etc. 1 by 11 is 0.090909. 8 by 13 is 0.615384, 615,384, and so on. So always it will be recurring decimal to be repeating. There will be no fixed part. But when it becomes a mixture, a recurring fraction other than the previous two, but either it is neither purely power of 2 and 5, but also not ending into 1379, ending in something else, ending in 6, ending in 5, but not a purely power of 5, and ending in 4, and so on. It will be there will be fixed part, and a non-recurring part. So non-recurring part and a recurring part. Sorry. So 1 by 6 is 0.1. This is the fixed part, and 666. 8 by 15 is 0.5 and 6. These all are discussed currently. Length of the non-recurring part is the case is length of the terminating decimal discussed earlier will be the greater one between maximum power of 2 and maximum power of 4. Either terminating decimal, number of digit, all these non-recurring part will be the highest power of 2 and 5 in the expression. Here the highest power of 75 is inbuilt here. Highest power of 5 is here 2, and so 2 and 5 both are 20, this one. So therefore it is 2 digits are there. Here highest power was 2 was this one, 3. There was 8 involved here, so therefore 3 decimal was there. So this is explained here. You can go through this one. You can explain how it is coming actually. This particular thing is coming, how it is coming, and transformation from fraction to decimal form and decimal to fraction. You can go through all repeat. I mean, need not go through that. Then actually the major thing comes here. This I just tried whether by Nichilium this whole fraction can be done, but it will be same as the cumbersome. But actually the recurring decimal can be best handled by Vedic one-line method. This is just from Excel sheet part. There is Excel. Actually, those of you learned Excel can separately contact me, and I'll tell you. It's very interesting how through Excel the recurring decimal part, recurring decimal calculation using Vedic one-line method can be done. So there's some screenshots are there. Now Vedic one-line method. So it will be ending up with always the denominator should end up in 9. So then only Vedic one-line method will work, because there is a relation with a binomial expansion. That you can that is there. You can see this is 1 minus x to the power minus 1 coming from this transformation. Now, if it is 1, 3, and 7, you have to multiply both sides of both numerator and denominator by 9, 3, and 7 respectively, so that denominator ends up in 9. So therefore, always this one-line method, or I sometimes call it Vedic binomial one-line method, because the binomial theorem is somewhere involved here. It is the background. I talked about background algebra always. So this is the background algebra is binomial theorem. Now I start with the 1/19. Okay, anyone remember this procedure? If everybody clearly remembers, I need not repeat. All are open?
Yeah, all are open, all are silent.
So should I repeat the procedure?
Please repeat, sir. Please repeat.
Yeah, yeah.
So it's already 7 and just keep in mind, it's 7 o'clock now.
It is 7 o'clock. So yeah. So yesterday I told that I'll take up to 7 o'clock only. Let's see at least because this gap actually, this is very interesting and one should not lose this. So better actually after going out of the class, you practice it. You will get it. I will, the description is here. I skip it.
Yeah, you can take this interesting thing after the pradhana for the people who are interested. Otherwise, you can
Yeah,
go
yeah.
back with the
Now
class.
it just so 1 or 2 minutes I take this one. This is
Right,
like this.
okay, carry on. Okay.
1/19, instead of dividing by 19, I divided by actually 2. This ekadikono purveno. So 1 plus 1 is 2. This 9, before 9, 1 is existing. So 1 plus 1 is 2. Instead of dividing by 19, I divide by 2. So 1 by 2 as if I am dividing 1 by 2, and 0 becomes my quotient on 1 remainder. This remainder will be my next tens digit, so that it becomes 10, looking like 10. 10 divided by 2 is 5 remainder. Sorry, 5 quotient and 0 remainder. 5 quotient and 0 remainder. This remainder I put in this one, left part. Again, 5 divided by 2 is 2 quotient, 1 remainder. Okay, this becomes 12. 12 divided by 2 is 6. Again, this some 0 I may not write also. Here for clarity I have written 6 minus 6 divided by 2 is 3. 3 divided by 2 is 1 quotient, 1 remainder, and it becomes 11. 11 divided by 2, 5 quotient, 1 remainder. Again 7 quotient, 1 remainder. 8 quotient, 17 by 2. So 8 quotient, 1 remainder. 18. 18 divided by 2 is 9. 9 again becomes 4 quotient, and that way it goes. And there also another thing is shown, that this actually is 9's complement. See, it has 18 length, 18 digits. 19, 1/19 will have 18 digits. And from anywhere you can start. Suppose that I'm giving a work of doing 14 divided by 9. 14 divided by 9 will be starting from here. 0.73 and so on. It will go like that. Anywhere I can start it actually. It will be the one cycle. So, but the half cycle I can see 9 minus 0 is 9, 9 minus 5 is 4. Everything is subtracted by 9, you will get the other one, this one, here to here. This is the first first 9, and this is second, this 9. You'll find that always, this for example, this one, okay, always this with this one. Always you'll find that, like for example, here and here, this add up with, you can write it below each other. And opposite thing also can be done. It can be done from right to left also, like 1 into 1 into 2 is 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, as 6 I write here, 1 as a carry, 6 into 2 plus 1, 13, 13 3 I write here, 1 into 3 into 1, 3 into 2 plus 1, 7, 7 into 2 is 14. That way, right to left also. And somebody wrote a paper on this one. Without knowing, without admitting that it's coming from Vedic mathematics, wrote a paper, and it is got paper board published in international journal and so on. So these are not very trivial things. very not unvaluable, they're very valuable, you can say. And this one, so here also I come to now anything n by 19, it can be relatively, you go through that by proper method. I can say this is the one line, but this one line gives the answer of all the fractions. That is very interesting. All the fractions from 1 by 19 to 18 by 19. There will be 18 possible fractions with 19 as a denominator. So it is 1 by 19 to 18 by 19. You tell me, anybody can tell which will be the answer of 9 by 19? Whether people got it, because already it was discussed in broad, very broadly in the first part. I want the answer for 9 by 19.
Yeah, you can speak out, Patarji. Yeah, he has written on the chat box.
Oh, so
Yes.
please tell me.
Yeah, he has written in the chat box, but he
Sir. So he
Right.
can take a separate class, I think.
Right.
So I skip here. Now I have shown you 29 also. 29 I wrote like this. So this also I instead of dividing by 2, this Ekadekano Purmeno, this 2 plus 1, 3, I divided by 3. So 1 by 3, I will start with like this, 0.03444, this one, 8, and then I can halfway, it is actually, there will be 28 digits. So after 14 digits, I may not do the procedure, but instead of that, I can simply subtract from the quotient will be add up to 9, so that I subtract from 9, and here this 2 is the number, 29, the 2 is there, so this remainder will add up to 2. So I can complete these things without actually dividing after this. When after 14 digits, I can simply subtract it. And here also, I can all the 1 by 29 to 28 by 29, all the answers are here. This is most interesting. Here also I can do from right to left. 1 into 3, 3 into 9, 9 into 3, 27, 7 comes here, 2 comes here. So Patarji can take all these things privately. That will be good. N by anything n by 29, that below column comes here. 59 I have shown it through Excel sheet I have shown here. The explanation of the Vedic one-line method, as I told, comes here actually. So this is the expression. Why modify it? 1 by 10n minus 10 into something minus 1. It is here. So it is very clearly written here. So that is the m by this thing, and finally comes here, and anything instead of 1 by something, m by something, and then this only m comes here, and then this becomes my formula. And other denominator, I have to multiply both sides. 1 by 7 becomes 7 by 49, and follow the same procedure. 1 by 13, 3 by 39. You have to divide it 3 by 4. Why 4? This 3 plus 1 is 4. Here, why 5? This Ekadekano Purbeno. Purbeno of 9 is 4, and 4 plus 1 is 5. So that way, all the different fractions can be done. Multiple cycles. You can go through this one. And the challenge comes when denominator ending in 1. I have to multiply both sides by 9, and then because it becomes very big. And I wanted to avoid dividing by 21. I end up in dividing by 19. Okay, very big. So instead of that, binomial expression itself I modify and follow a negative method. 1 by 1 plus 10n plus 1, like 21, 31, 41, etc. So here it comes, actually negative comes. As a negative comes, the procedure becomes changed. And this is actually very a tricky one, 21. But this 41 is becomes, this you can go through. There are positive and negative methods, both can be applicable. And then you find that very big numbers are coming here, big remainders are coming. Here it is sometimes negative are coming. So here 14 by 41, I have given a example. So if I divide it, become 3 becomes my quotient and 1, 2 becomes remainder. So earlier, had I divided by 39, I would have gotten with next step would have been 23. This 23 divided by 4. But here, what is the 20 plus 3 is 23, but 20 minus 3 I do, so 17. With 17 I proceed. So it becomes 4 becomes my quotient and 1 remainder. So that actually you can go through. This is the negative method to avoid such big numbers, big division by big numbers. So here, this much only I discussed. Periodicity, you can go through this one. Divisibility actually is, we learned divisibility by 2, 9, and 3, 9, 11, etc. But divisibility by 7 is avoided. Since 7 is can be done by oscillation method. And oscillation method, this algebra is given here. Algebraic expression of the oscillation method is given. So oscillation method, you can, for example, divisibility by 7. So 7, suppose 7, what I do? 7 actually, this 5 I have to do it. So I have to use 5. For example, here, this example. 343, 34 plus 3 into 5, 49. And 49 is divisible by 7. So 343 is also divisible by 7. So that you can go through the oscillation method. If any problem comes, you can discuss. All these things are discussed, composite numbers. Then the multiplex oscillator is there. This also we actually discussed in detail earlier. Now I start with some content of the second level course. State division, Borgomula, remainder theorem, differentiation and factorization, and applicability between hexadecimal. State division more general. What is the procedure of state division? It is one of the courses someone wrote in the in a paper in a different format. I will just find it. I will try it again. But here in this format, whatever is there in the Bharati Krishnada's book, that I am following here. Say this is the state division 38982. This number I'm dividing by 73. I write in this fashion 38982 and 73, 7 I write here, 3 I write here. Now, first I give that what is the first digit of my quotient will be. So it will be, if I divide this 38 by 7, this 5 will give my first digit of the result, which quotient. So this I write here, 5. Okay. And remainder I write here, 3, remainder. Now that remainder will be there and that will make it 39. But this 39, I have to subtract by the other digit of the my dividend multiplied with this by, so it will be deficient by, this will be have to be subtracted, becomes 24. So in algebraic expression, this can be proved why it is so. You may find it very complicated compared to, because we have already practiced in a particular fashion. We also divided and subtracted. Here the subtraction comes in a different format. This 39, I'm subtracting with 3 into 5, 14, so it becomes 24. Now 24, I again divided by 7. So 24 divided by 7 is, quotient is 3 and 3 becomes my remainder. So again 3 into this 3 and 3 write this one. And this 3 into this 3 into 3 is 9. I subtract this one, okay, 38 by 9. So it becomes 29. Okay. This 29 divided by 7, it becomes 4 quotient and 1 remainder. 1 remainder with the other next digit of this my dividend becomes 12. And 12, when 4 into 3 is 12, 12 minus 12 is 0, so it becomes 0. So finally, when it becomes 0, I end up in the division. Say, had it been some, say, 1 here, so 1 would have been my remainder. So 534 is the question. Is it clear? Anyone? Should I repeat?
There is no one answering.
Please repeat, sir.
See, 38982. This I'm dividing by 73. I have to handle different digits of this original 38982. You remember, actually, I will make better. With a different color, I just, this is my, this is my original dividend. Yeah. Now I am dividing 7 by this 38. 38 I am dividing by 7. So 5 becomes my quotient and 3 becomes remainder. Now I take up the next digit of my dividend. Okay. And mixing with the remainder of the result of the first one, this 39 becomes my one number.
98, 331, 534.
39 becomes will become my a number have to be formed. But actually, so far I have not used 3. So what is the contribution of 3? This contribution of 3 will be 3 multiplied by this 5 is 15. I subtract 15 from this 39. So it becomes 24. So 24, why I wrote 38 here? Because the 38 has copied it here. 38 would have been my first dividend part actually. Now next dividend part will be 24, which I have to divide by 7. So 3 becomes my quotient and 3 becomes remainder. These 3 mixing with the next digit of the division becomes dividend becomes 38. But again, I have to use this 3. So 3 times 3 is 9. I subtract 38. I subtract this 9 from 38 and becomes 29. 29 will be my next dividend, part dividend by 7. So 4 becomes my quotient and 1 becomes remainder. Again, this forms 12. So I have to use now, I have used 7, I didn't use 3. With 3 I am using 3 into 4, 14 have to be subtracted from, sorry, 4 into 3 is 12. 12 has to be subtracted from 12, becomes 0. Suppose had it been 4 here, suppose instead of right, I write 4. So here would have been 2. 2 would have been my remainder, and 534 is the quotient. I think it is clear, na? I take another example.
Person who wanted to things to be repeated should answer whether he has got it clear or not.
Yeah. It is clear, sir.
Okay.
Somebody wrote, actually, I didn't copy it. I can also write. It is easier in one another format can be written. But is it here also okay? By cross, box. So this is my dividend.
The second step, somebody wants to know.
Oh, where I'm using this second digit of the divisor.
Could be, I think. I mean, Lakshmi Garu, you can unmute yourself and talk. Say yes, no.
Okay, sir, okay.
Right.
60 divided by 8, that part I could not understand.
Which one?
60 divided by 8.
Oh, 60 divided by 8. See, 7 into 8 is 56 plus 4 is 60. So 7 quotient and 4 remainder.
Okay, second digit, okay.
Now it becomes 45. And 3 into 7 is 21. I subtract 21 from 45, becomes 24.
Okay, 24 into divided by again 8. So how do we know when to use 3, last digit?
Oh,
Out of-
after going through from 1 division by 8, I have to basically subtract these things. Also subtracting 3 into 3 and becomes 0, 9.
Okay, 3 into
3 into 3. Suppose had it been instead of 9, it would have been, say, 59, something else.
yes.
60, say for example 60. So 60 here, you can see that 46 it will be, and it will be 25. And again, it will be, one would have been my remainder. That with 1 and 0 are connected to 3 into 3 becomes 0, and then becomes 1 would have been. You can say, this example I didn't keep any remainder.
Okay.
So this is
Okay,
okay?
sir. Yes. Again, I'll work it out, and any doubt is there, I'll ask you again tomorrow. Yes.
Here, let us take up this example.
Thank you, sir. Thank you.
Here, say 5, 4, 288. I'm dividing by 72. So 54 divided by 7. 7 becomes my 7 49 plus 5 is 54. So 5 is remainder. So 5 and this 2 becomes my next things to be considered. But I use this thing. I subtract 7 into 2 from this one. Becomes 38. 38 divided by 7 is 5 quotient 3 remainder. Again, this becomes 30, forms it next digit of dividend is used, is 38, and 38 I subtract 5 into 2, so this becomes 28. 28 again by divided by 7 becomes 4 and 0, and becomes 08, and 08 I 2 into 4 is 8 and becomes 0. Actually, I thought this is the first time introducing, so I didn't keep any remainder. The remainder could have been taken. Okay. Now, so anything about the state division? I will repeat again if required tomorrow.
Nast Guruvarya.
Now I come to Vargamula, square root. Anyone remembers the square root method of the normal, what I did with square roots?
No, sir.
Earlier, the conventional method of square root?
Is it prime factor, sir?
The way I learned in childhood, slightly it is modified later, but I still follow this one. So suppose I have to
Prime
do
factor.
square root of 625. What do we do? Now 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9. So which overshoots this one?
So
No, first step is that from right side, I group into 2. Yeah. In Vedic mathematics, we didn't group actually. Here it is grouped. So 9 into 3 into 3 becomes 9. So 3 cannot be the first digit. So what I do? I write 2. 2 into 2 is 4. Now this becomes my 225. Actually, it comes from this formula somewhere. It is the opposite of this one is a plus b whole square is a square plus 2ab plus b square. In the background, okay, in the background this one there. So therefore, the next procedure is, because of this 2, I have to multiply it by 2, becomes 4. Now, I have to find a digit which I will put here. Suppose the digit is x.
Sir, in that formula, a plus b whole square equal to a square plus 2ab will be there.
Oh, sorry. 2ab. Your alert will be very good. Thank you. 2ab plus b square. So now, here I write something, not is into, it is x. So this x, I have to find one x, that same x and this x here, when multiplied, it comes to the nearest to this one. So I put one, start with 1, 41 into 1, 41 into 1 becomes 41. 42 into 2 is 84. 43 into 3 becomes something, 44 into 4, 444, 176 or something like that. And then I find that 5 is the one, I put 5 here and put 5 here. And this 5 into 45 becomes 225. Okay. So that was the conventional procedure. You remember? Let us take a bigger number. Okay. Again in instead of 10 to 25. Actually no, 5 should not be used. Let us use say 60. Seven, 3, 9, 6. So what I do in first step in the conventional method, I block up 2 from right side. Then what should I do? Seven into 7 is 49. 8 into 18, 64, and 9 into 9 is 81, more than this. So I write
ఇప్పుడు వస్తుంది నీకు
8 into 8 is 64. So it becomes 996. Then becomes 8 have to be multiplied by 2, 16. Then I find that I try with different numbers, and then finally I find that when I put 6 here and 6 here, 6 into 6, 36, 6 into 6, 36, 38, 39, and 6 into 1, 6, and plus 3, 9. So 86 becomes 9. So that was my conventional procedure. Let us see what the procedure of the Vedic procedure. Here also, first we group into digits of 2, 119716. 119716. But we do not group, we will separately group. But last one, this 11. This will be a smaller number. So actually I group like this. This one, and this one is remained. So 3 into 3 actually, so 3 square is coming to near to that. So I write 3 here. Now this I double. Earlier also I doubled it actually. So 3 double 6. 6 I put in the left. And 2 was my remainder. So after 3 into 3, 9, 2 became my remainder. This 2 with 9 becomes 29. The 29 divided by 6 gives this 4 and 5. 4 becomes my quotient and 5 remainder. Okay. This 5, when this 29 I have written here. Okay. This 29 I have written. This 4 and the 5 quotient, this 5 with 7 becomes 57 I wrote here. Now next to what is it I have to do? The subtract square of 4. So 4 becomes my something. I subtract square of 4 from 57. Okay. So 57 minus 16 is how much? It becomes 41. This 41 divided by 6. It looks very thing, but actually the algebra can be founded, and algebra will clear it. 41 divided by 6, the 6 quotient and 5 remainder. This becomes 51. From this subtract 2 into 4 into 6. Now comes actually the thing is actually, I'll tell you the thing. Actually, it comes like this. A plus B plus C
A square plus B square plus C square plus 2AB plus 2BC plus 2CA.
Yeah. B square plus C square.
Mhm. Mm. BC plus 2CA.
But here actually procedure will be different because A actually is this one. Here A is 300, B is 40, and in background because I don't know the result, I can tell you. A is 300, B is 40, and 6 is the C. So accordingly, you have to do with proper the tens power and so on. Actually, that is in this particular procedure actually is doing step by step this one. First, I square this one. So basically, it's a square. The a square part is over when I squared these 3 and subtracted from here, becomes 29. Now why I this twice of that? This twice of this will be used twice A. See twice A. Actually, it is, I don't write here, it actually twice A, and then I use B and plus twice A. This procedure I first did like this, twice AC and then twice BC. And this square I subtracted from, so see this is the square. I squared this one, no, 4 into this one. This is the B square. This is the B square. So again, if I do, but how is the procedure I am doing it, you'll understand. If you know the background of the background algebra, you will appreciate it. So 41 divided by 6. So basically, I am 6. Why 6 again? This twice A. 6 is the twice A. So 46 I am dividing by 41 divided by 6 to get 6 as quotient and 5 remainder. And with the 1, I get 51. Now from 51, the third digit of this 5 and 1, 51, third digit of the result. Now subtract 2 into 4 into 6. Why 2 into 4 into 6? This is the BC. 2 into 4 into 6. So 48. 48 again it becomes 3. Only 3 here. And then this one.
Thank you.
Becomes 48. 51 minus 48 is 3. And 3 divided by 6, what I'm doing, it becomes quotient 0 and 3 as remainder. 3 as remainder. And these 3 3 and 6 give me 36. This is actually the AC. And I subtract it and it becomes 0. So this matches. Should I repeat?
Two from right. Okay. Square root of 55. Square root of 11, which is 3.
Another example I can get. Oh, sorry. square root of 552049. Seven into 7, 49, and 6 is remaining. So I double it and keep it here handy. It becomes 62. 62 divided by 14 gives 4 and 6 remainder. This mixed up with 0 becomes 60. Now subtract square of 4 from the square. Square of 4 from 60. So it becomes 44. 60 minus 16. Okay, 44. This 44 44 when we divide by 14, it becomes 3 quotient and 2 remainder. So this 3. Actually, if I know it is perfect square, my if I surely know that it is perfect square, my this finding out the thing ends up here actually. But actually, you have to match whether I have to verify whether it is matching, it is a perfect square or not. I may not know it in the beginning. So now the third digit is already over. C is also the A, B, C. Like C is there. So I have to now AC I have not used. So 14 into 3 is 42. Two AC. Third digit of the result, and remainder is, so actually it becomes 3 we put and 2 is, so 2 mix up with this one, the next digit of this one becomes 24. Now when this 24 and remainder is 0, so 0 divided by this 6. Two times of this one. First decimal part and 9. Subtract it. So finally it matches. Subtract the square of the third digit from this one. (14 into 3 plus 2). 44. 44. This is the 2BC. This 2A, this is the 2A. 2A I have written here. But 2B or 2C I have not written. So 2BC is actually 2 into 4 into 3 is 24. This was 24. How 24 came? This is that these two came from the, when we this 44 came earlier. How 44 came? Now it is 60 minus 60 minus 4 square, b square. 60 minus b square basically. So it is actually 44. Now this 44 is divided by twice a to produce the c, twice ac. I have to produce c. How c comes? Now, I have to know the c because so 44 when divided by this 2a will produce my c as 3 as a quotient and 2 is the remainder. The 2 and 4 becomes 24. But again, this I have to subtract it, this because there one more term is there in the a plus b plus c whole square, namely twice bc. This twice bc, 2 into 4 into 3 is again 24. It matches, so it becomes 0. So this 0 and 9, but so far I have not used c square. This is the 2bc. So far I have not used c square. C square I used in the last, that when this 24 matches to 0, and but the last digit of this one remained 9. This becomes 0, 9, it becomes 9, and then 3 square is 9. So it matches with 3 square 9 and subtract and becomes 0. So I know that 743 is my result, and there is no remainder. Remainder becomes slightly more complicated, and maybe that tomorrow I can take up such an example. What is the time now? So something is understood, no? You can't say that you have not understood anything.
Sir, we have understood, but it needs practice to grasp.
Yes, practice and you follow the procedure, and also match with this background algebra, with the tens part of this, because you know that maybe that tomorrow I'll try to, if I get time. Actually, time is very short after some other problems. But actually, it is interesting. Actually, step by step, it can be written. Somebody can try also. That actually this basically
Yeah,
this
time is
700.
just 10 minutes there. So what we do is take 1 or 2 questions and then go for pradhana, and later after the pradhana we can have few more questions. Okay?
Yeah.
Okay, thank you. Anyone wants to have any questions? Raise your hand and we'll take it up. Any questions, please raise your hand. I think
Algebraic expansion of square root procedure. Let us take a bigger one. This you can this have learned. This you just go through. This will be similar to that, but here you do a bigger one. Four digits. A plus B plus C plus D.
Gautamji, a small information.
Tomorrow I can take up this.
Yeah, in the notes that you have provided last time, I saw a very simpler way of finding out the square root. Here it's slightly complicated. I mean, not complicated, but then is there any other method that you had in your notes, or this is the only one?
Earlier.
Because I only saw your books, no other text. So where I was trying to do the square root, I mean, in the basic course, then I found it very simple. I mean, it's very useful. Square roots, Vedic maths is very useful. That's what I thought. But here it looks a bit complicated.
Complicated.
Yeah. So is there any other method also? That's what my point is.
No, the conventional method is there. Conventional method is good also.
Not the conventional method. I am talking about Vedic mathematics. Conventional method I know, but Vedic mathematics I felt it was much more easier Maybe, I don't know, maybe I'm wrong. I'm just wanted to know if there is any other Vedic mathematics method for square roots.
So do you remember? Can you show me that notes? What?
It
can
is
you
your own
forward me?
notes.
Huh? Oh, no,
Any,
but I'm not recalling it. So
Right,
can
right.
you kindly forward it to me?
Yeah, I'll do that.
Okay.
Later I'll do that. I'll first check up myself and then do it.
Okay.
Okay. Right now we go for Prarthana Babu Garu.
Okay.
Okay, let's go for Prarthana.
Yes, sir.
Yeah. Jai Shri Garu.
Yes, sir. स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जना सुखिनो भवन्तु समस्तसन्मङ्गलानि सन्तु स्वस्ति ధన్యవాదాలు గురుగారు
ధన్యవాదములండి. Let's go for Janaganamana now. Chala Chittibabu garu.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय
Jai
जय
Hind. Okay. Now let's go for any question answer session or
Yeah, we should go for question and answer session now. In case someone wants some revision of the things that have been taught today, including the straight division and the square root, these two topics. No one has any question? Yeah,
పూర్తిగా ఇంకా అర్థం కాలేదు కానీ ప్రాక్టీస్ చేసుకుంటాం గురువు గారు
okay.
చెప్పడానికి అంత టైం
Right,
సరిపోదు అందుకని
right,
అడగలేకపోతున్నాము
అడగండి ఇప్పుడు టైం ఉంది కదా అడుగుతున్న టైం ఉంది అడగండి ఏమన్నా అంటేనా అడగండి
Questions can be asked only when we do practices. Then
Right,
doubts,
okay.
doubts will arise and then we can ask questions.
right.
Hmm.
Point understood, but in case in any of one particular step if you have having a doubt, you can ask so that that doubt can be clarified, so that you can do the practice at home leisurely. Anyway, in case there are no questions, then it's up to Gautam ji.
There are 5 more minutes. I can take one example here for just
Yeah,
for
you can take one more example here.
with the same number of digits. Tomorrow will be higher digits will be teaching. So again, 6, 8, it's 25, 06, and 68. So 68 when divided by square rooted becomes 8 and 4 remainder. Okay. But 8 this twice A, I keep it aside. This A, my A is defined. Now, from there, this becomes 40. So 40 divided by 16 gives my 2. So basically, I am subtracting this twice. What happened? My sharing got off.
Oh, just a minute. Why you're just
It says that
just
I
a minute.
cannot share.
Yeah, I know. Just a minute. బాబు గారు co-host చేయాలి గౌతమ్ గారిని, then only he can present.
1 minute. Yeah. Okay.
No. Yeah. I came back here. Yes. Now, this is twice A. So this 40, so 40 divided by 16 gives 2 as a quotient and 2 as
Excuse me, sir.
2 as quotient and 8 as remainder. So this 8 becomes my B here. And this 8 remains. With 8 and 6 becomes 86. With the 86, I have to this square of 2. So B square, I am subtracting from 86 to get 82. This 80. And 82 divided by 16. Basically, I am now twice AC. So to know the C, I am dividing this 82 by 16. So it becomes 5 quotient and 2 remainder. So 5 becomes my C and 2 remainder. It becomes mixing with this 2 next digit of this one of the main square this problem becomes 22. Now, so far I have not used 2AC, 2BC and C square, the lower digits, because actually it is AX plus B, AX square. Basically, it is AX square, or not ABC, AX square plus, because X is there in the background, X is 10, X is 10. This BC is this, so I have to subtract this 22, this 2 into 2 into 5, 20, so it becomes 2, okay, and 2, it is divided by 6, what is 6? This one. No, it should be 16. So basically AC. No, no. Maybe copied somewhere wrongly. So anyway, this is becomes 0, 2, and then I have to subtract from, it becomes 25, and then square of this 5 is 25, so it matches to this one.
Should be 16 actually, yeah.
16. Here also it will be 14. I'll correct them. So it becomes 0 and these things. And just practice, it will come here. So tomorrow I'll cover this. Now algebraic expression, I do it. The square of the expression is this is actually this. All the excess power comes. That's what is coming. No, this big this thing actually 10 square. So it is 3 digits, but when you square it, it becomes up to 10 to the power 5, 10 to the 5, 10 to the 4, and so on. So it comes like that. So x to the power 4, 10 to the power 4, 10 to the this one all comes. With 3 digits, I can finally get 10 to the up to 10 to the 4. So these also are there. So when I group it in the power of x, so it becomes like this.
If you found the video useful, please click the like button.
So and similarly square. So see, I did like this. No, first of all, I found out what is the square that is best fitting. So by a square of these things. Then I found that remainder. Then this actually cube. So cube 2ab is the cube, and this is actually b square plus 2ac. Both are actually coming to the next one. So therefore, I did square of that second digit, and again the twice a I kept some aside. Twice a I used and subtracted, and then I came to that, and then I came to this part, and then I came to the by subtracting the b square plus and dividing, I got C. Here the step I got C. This is the step I got B, and very first step I got A. Then rest of the thing, whether I verified, twice BC also I subtracted and divided it, and to get the whether there is any remainder or not. Then finally I subtracted this C square. This is the lowest point. This is the unit digit of that. So to match whether any remainder is there. And here it will be more complicated with when the result becomes 4 digits, it can go up to 10 to the power 6. 10 to the power 6, and then it can go. Tomorrow we'll cover that and step by step. So many different. So twice, even if I keep it aside, twice is coming here, and here. 3 places are coming. But sometimes it twice B also came, twice BD, twice CD. Group in power of this thing. So this is actually this one. B square plus 3, BC plus 3 become x cube. X square becomes C square plus 2BD, and X becomes 2CD only, and D square. So this up to tomorrow we'll cover. Remainder theorem. Any time is there? Okay, so any question?
I think there are no more questions. They have to digest what is being taught. And tomorrow they'll come out
Previous
with the
place.
questions. Yeah. Okay.
One more time, previous place, ax square plus bx plus c is.
Yeah. Yes, ax square plus bx plus c.
Oh,
Basically, x is nothing but x is 10. X is equal to 10. So what is the 10th power? According to 10th power, it is all happening.
that's good. 1 minute, sir. We are writing this.
No, these are already shared. The whole presentation is shared actually.
Hmm.
Okay.
1 minute, sir.
Okay, I think,
Yeah.
Gautam ji,
Hmm.
we can stop here because people have taken notes of whatever you have said.
These are actually all, the whole presentation is shared.
It's already there, given to them, I think, notes. So let them digest
Yeah.
and then we can take up tomorrow. Yeah. So,
Tomorrow I have to cover also so many things like remainder theorem.
yeah. So,
The differentiation and factorization is a new one actually, quite new
Yeah.
concept.
Right.
How it is happening, and start with factorization and then I go
Yeah.
for this one.
Have a very small package for tomorrow so that you can complete and explain it also. Instead of having a larger content to be taught. Okay, Babu Garu, I think we can. Babu Garu?
Those are interested can take a small, exercise. I actually, in the second level, I should have given more bigger numbers, slightly with having carry. I'm just preparing them. So there should have been little earlier. I have to go earlier these methods. Here, kindly take with wherever there will be carry. Okay. Carry. See, if you write, for example, this number you can write. There will be a 2 here. Bigger number, say 897, 887. So put 887 into 893 or 873. Please take up the exercise. Here I have already given 86 into 84. So instead of all 9,000, you do 8,000.
Yeah.
Maybe this one is a little smaller.
Okay, I think.
You just this 3 exercise you do for tomorrow. You can.
Okay.
If any problem comes, please.
Yes.
I was
3
just
comes
preparing.
for homework.
Homework.
Yeah. Okay. Babu Garu?
Okay.
Okay. Let us stop recording.